So in this unit, we're talking about functions. And before we start talk about functions, we're talking about relations. So a relation is where you're mapping, where you're pairing input values, which are your x's, with output values, which are your y's. Okay, that's a relation. A function, all right, is where it's a one-to-one. There's each x value has one y value. All right. So with a function, you can predict what is going to come out. You put in a number, and there's only one number that could come out. You know what it has to be. Looking at, so what goes into the function, right? What goes in is your domain, right? That's your input, and then this is what is your output, is the range. All right, so there's different words you'll see for domain and range, or letters. Domain is the x value, range is the y value. What goes in, so we can say input, output. If you're looking at, when we talk about looking at a graph, these are your x's, these are your y's. X is also your independent variable. If you're doing an experiment, that's what you change. And then what you're going to measure is your dependent variable. Dependent, there we go. Dependent variable will be the y's. The output depends on what you put in. What you get out depends on what you put in. That's basically what a function is. This y could also be like f of x. Right? That also means y. All right? That's probably enough words for that, and we'll think of some other ones later. All right, so now we have, like I said, an input and an output. The input is the domain. The output is the range. All right, and we can write that as there's different ways you can write it. You can write it as a table where you have your x values, right? This would be the domain, and the range is your y values. Notice it's kind of alphabetical. We usually have x's first. If you're going to make, these would be points on a graph, right? Where you have your x's first, and then your y's, domain, and then the range. And so this is what we're talking about here with an ordered pair. All right, you have an x value comes first, and then you have your y value. And it's alphabetical, if that helps you remember. You can also show these relations or functions with a graph, which we do a lot of in Algebra 2. So you just take these points. I need to calibrate this board. I might have to put this on pause. So this point, you have an x value of +1, and then a y value of 0. Okay, so this is my input, and this is my output. Okay, if a 1 goes in, a 0 is going to come out. And let me put this on pause so we can. Okay, so we can show these relations as a graph. We can also, and you need to be able to go from one to the other. All right, so here are the different ways you can show this. And then given a certain way, if you're given a table, some people call this a T table because you've got x's and y's, like a T. So my domain is going to be my list of x's, and it's a set. All right, so we'll use our set notation, and you go from least to greatest. So we got -9, 2, 3, 5, and 8. And that just makes it easier to see what you've got, if there's certain order to it. And then for range, that would be, this is going to be my range, right? This is the domain, x is the range, or excuse me, domain, whatever. Okay, range is the r's. I'm trying to go fast. So here we go. Range is the y values, right? Domain is the x value, range is the y values. So range would be, what's our smallest number here? -3. and then 1, 2, and then 14. If you have a repeater, which you could have, you don't write it twice. You just write everything one time. All right, so now this would be a graph of the function or the relation. And so if I'm looking at my domain, I'm going to write down the x values. So I'll go ahead and write in the coordinates of these points. So this would be -2, 3. This point is -1, -2. This point is +1, +1. And then this point is, let's see, over 3, down 1. So 3, -1. And if I see the coordinates, then it's easier to write down what the domain is. All right, the domain is the x values. So I've got -2, and again, I'm going to go small to big. So -2, -1, 1, and 3. I'll put commas in between. So that's the domain. Those are my input values. The range is your output values, so range is y. So that would be the second number. So going from least to greatest, now domain goes left to right. Range is going up and down. So I'm going to go from the lowest number, which would be -2, then I'll go to -1, I'll go to +1, and then up to 3. Okay, so range-wise, I'm going up and down. Left and right is going to be your domain. Okay. All right, so now I've got these points here. So same thing, domain. I'm going to look at the x values. So these are the x's. So I'll go, what's my smallest one? 0, 3, 5, 7. Okay, and then the range is y. So the y values are these. So let's see, that would be -2, 1, 3, and 4. Okay, this is just a list. These are, they don't go together. All right, there's no correlation there. And that's it. That's all domain and ranges. Okay. Now we're looking at to see if you have a function, every element in the domain is paired with exactly one element. All right, that's why it's a 1-to-1 relationship. All right. Here I have this function. If I put in remember this is x is your domain. If I put in a 2, a 0 comes out. If I put in a 5, I know I'm going to get a 3. If I put in a 3, I know I'm going to get a 4, and so on. All right. Now here, there's a problem. This is not a function, because if I put in a 4, I could get a -3, right? A -3 could come out, or a 0. That's not any use to me mathematically. We use functions to predict what's going to happen. So if I can't predict what's going to happen, it's not useful. So this would be if my y's repeat, right? If the y's repeat, that is bad. All right, that means not a function. Oh, excuse me, not the y's. The y is not repeating. Those are different numbers, right? That's a -3 and that's a 0. What's repeating? The x's. Okay, I rushed in on Saturday to try to get this done, so I'm not quite with it. So yeah, the y's are not repeating. The x, right? The x's are repeating. Okay, so there's actually 3 numbers that it could be. It's really useless. All right, I put a 4 in, I could get a -3, a 0, or a -1. So that means not a function if the x's are repeating. Okay, so, and then if you look at these, this is a table, right? That's a table. Now we're looking at ordered pairs. All right, and again, if the x is repeating, that's a problem. So this is a function because I got 5, 7, 4, 1. The x does not repeat. All different x's, right? But here, I have 3, 3, 3 twice. So 3 goes in, I might get a 3 out, and I might get an 8 out. Okay, again, the x's are repeating, so that is a problem. That's why it's in this not a function category, because you have these 2 3s here. All right, so you can see it as an ordered pair. And again, now here we are with the graph. How do we see this problem as looking at a graph? All right, well, this is good, right? All these don't repeat. If I write the ordered pairs here, I have -3, right? -3, -3. This would be -1, 1. This would be +1, 0. And this would be +2, 1. So do my x's repeat? No, they don't. All right. Over here, if I put in these coordinates, I can see, I'll just start on the left, that's a good habit. So -3, 0 is this guy, right? I go over 3, up 0. This guy is +1, -3. And this guy is +1, +3. And this one is +3, -0. Okay? So now notice this is in the not a function category because right here, right, I have a 1 and a 1. So 1 is going in, and I could get a -3 or I could get a +3. Okay? So my x is repeating, right? X repeats, so that's a problem. And what's nice is if you have it graphically, you see this vertical line. All right? You have the vertical line test. All right, which this one fails. All right? If you have 2 points on this vertical line, that means your x is repeating. All right? Because the equation on this line is x equals 1. X is always 1. All these points on this line have an x-coordinate of 1. And that's the equation of that line. So that's the vertical line test. And you'll see that over and over again as a rationale. How you know, because we look at graphs a lot in Algebra 2. So that vertical line test is very useful. So over here, I don't have to write. There's an infinite amount of points here. I'm not going to write all these. So I'm just going to use the vertical line test. All right? So that is a function, okay, crosses once. Here, vertical line test, this is an issue, right? The vertical line test tells me that this is not a function. Okay, because my x repeats. Right? It's not a 1-to-1. All right? It's not 1-to-1. All right? I put in this number and I get 2. 1-to-2. All right? So, looking at these, we're just going to see if it says here, always read the directions. It says use the vertical line test. All right? So, here we go. So is this a function? Yes. It's getting vertical, right? But technically this is technically going to the right and this is going to the left. Even though it kind of looks like it's vertical. It's not exactly. This one, is this a function? Ooh, right here, right? Let's highlight that. That is a problem. That's our vertical line, right? Those two are on the same line. This point and this point are on the same line. X equals, it's hard to see what it is. Erase. 1, 2, 3. No, oh my gosh. 1, 2. Okay? So this vertical line, x equals -2. All these points have an x coordinate of -2. So that is like not a one-to-one, it's 1 to infinity. All right, so no, not a function. Okay, and then is a circle a function? No, because boom, boom. Okay, and why? Because you always have to say why. You could just say vertical line test. Right, or x's repeat. Okay. All right, excellent. Now we have a new notation here. This means we have a function, and the name of it is f. Functions have names just like you have a name. What is going into the function is written right here. This is always going to be your domain, right? What comes out, the whole thing here is the range. That's y. So let me make that easier to understand. X, oh, I'm making it in a different color. The x, right, is the domain. That's going into the function. Okay? What is coming out of the function is f of x, and that's the range. Okay, so x is going in, right, that's my domain, and then what's going to come out is what all of this is equal to. Okay, the whole thing, that is going to be the range. And I might have just made that more confusing, so let's do some examples. All right, here's a picture of it. X is the input, so that's my domain that's going into the function. F of x is another way of writing y, right? F of x and y mean the same thing. And this tells you what y, the definition of y, what it is going to do to the x. It's going to times it by 3 and then add 5. And the output is f of x. So you need to get, remember, that f of x means the same thing as y. All right, so here we are. We're given, you're always going to give, well, not necessarily. You're given something, right? You're given the domain in this case, and then you're going to compute the range. All right, again, it says find the range. Okay, the directions help you in math. They tell you how to solve the problem. Get out of the habit of just looking and zooming in on the numbers and the variables. The words tell you what to do. So it says find the range. And you're given a domain. So these are my x values that I'm going to put into that function. All right, and I'm just going to, I know what that means. And so now I'm just going to do what it's telling me to do. Basically, algebra is just substituting. So I have an x, so I'm going to do f of, and instead of x, I'm going to put in a -2. And then I'm just going to substitute in for x. So that will be -2 squared plus 3 times -2 minus 8. All right? And you can do that on your calculator. You can plug it in. You could use the store button. You could say -2 store x. All right, if I say -2, I'm going to say okay, so if we put those numbers in, we get -2 squared is 4, -6, -8. So -2, so I get -10. All right, and then I'm going to put in f of 0, and that is just substituting, so I get 0 squared plus 3 times 0 minus 8. All right, so that's -8. And then I'm going to put in f of 3, and then I'm going to put in 3 squared plus 3 times 3 minus 8. All right. So my x's go in the parentheses, so 9 plus 9 is 18, so that would be 10, and then I'm going to do f of 6. So we're just substituting in here. The 6 is my x. All right, you can use your store function or substitute everything in and use PEMDAS. So let's see, so 36 plus 18, actually I'm going to say I'll do 18 minus 8 is 10, so that's 46. All right. So all you do to find the range is you put the x, right? To find the range, you substitute for x, right? If I'm going to find the domain, all right, that means I'm given the range. The range is y. So I substitute for h of x, all right, into the function. Substitute for y. So now I'm going to put the -7. These are my y values, right? Range is y. So I'm going to put -7 in here. I'm going to say -7 equals, and this always messes everyone up. We're always used to substituting in for x. All right, so you have to be really careful when you're reading these problems. And then you just solve it just like you always do. Using your properties, the +9, 2x equals 2, divide by 2, x equals 1. All right, so that is the first element of my domain. All right, if I'm going to say I'm finding the domain, all right, the first number there is 1. Okay, and then now I'm going to put in a 5. All right, so I'm putting that in for the y. For h of x, right here, h of x's are y, so I'm going to say, now I'm going to put in a +5 equals, and x is what I'm trying to find. So I'm going to add 9. We get 14 equals 2x divided by 2, so x equals 7. Okay, and that would be the second element in my domain. I'm trying to find, this is find the domain, so it's a D for domain, and here's what it is. Okay, I've got a 1, a 7, now I'm going to put in an 11. All right, so now I've got 11 equals 2x minus 9, all right? Same thing, when I get 18 equals 2x, so divide by 2, divide by 2, so x equals 9. And that would be the third element, because this is a function, so there's a 1-to-1. So if I have 3 values in my 3 range values, I'm going to have 3 domain values. Okay. All right. So I think that might, oh, we still have more. I'm going to go ahead and stop that because that was a pretty long video. Good job.